When I bump one end of a long metal bar, the other end instantaneously moves. Can I use this to send messages faster than light? Welcome back to our channel. The idea of faster than light, FTL, communication has fascinated scientists and science fiction writers for decades. While there is currently no known method for achieving FTL travel or communication, recent research has shown that the instantaneous movement of long metal bars could hold potential for faster-than-light communication. This phenomenon, known as the longitudinal transverse effect, has led some researchers to question whether it could be used for communication purposes. In this article, we will explore the possibility of using long metal bars for FTL communication, the theoretical frameworks behind it, and the potential real-world applications and limitations of this technology. The phenomenon of instantaneous movement in long metal bars. What is instantaneous movement? Instantaneous movement, also known as superluminal motion, is the movement of an object from one place to another at a speed faster than the speed of light. As per Einstein's theory of relativity, this is not possible for any object with mass. However, there is a phenomenon in long metal bars that can give the impression of instantaneous movement. The role of long metal bars in instantaneous movement. When a long metal bar is struck at one end with a hammer or any other object, sound waves travel through the bar, causing the molecules to vibrate. Due to these vibrations, the metal bar slightly elongates, causing the opposite end of the bar to move almost instantaneously. This movement is so fast that it appears as if it is happening instantly, but in actuality, it takes a few microseconds. Understanding the principles of faster-than-light communication. The limitations of light speed. As per the theory of relativity, the ultimate speed limit in the universe is the speed of light. No object with mass can travel faster than the speed of light. This puts a limit on the speed at which information can be transmitted across vast distances in space. The concept of FTL communication. Faster than light, FTL, communication is a hypothetical concept that involves transmitting information across vast distances faster than the speed of light. Although it is not possible using the current understanding of physics, researchers have been exploring various theories and possibilities of achieving FTL communication. Investigating the possibility of sending messages with metal bars. How metal bars can be used for communication. The phenomenon of instantaneous movement in long metal bars suggests the possibility of using them for communication. By striking one end of the bar to impart a signal, it could be possible to send messages through the bar, with the opposite end receiving them in near real time. Advantages and disadvantages of metal bar communication. Metal bar communication has some advantages over conventional methods of transmitting information. For example, it could be used in environments where radio or optical communication is not feasible. However, metal bar communication also has some disadvantages, such as the fact that it is limited to transmitting vibrations and may not be suitable for transmitting complex information. Theoretical frameworks for FTL communication with long metal bars. Theoretical models for FTL communication. There are several theoretical models that suggest the possibility of FTL communication using long metal bars. For example, one model involves using a series of metal bars of varying lengths, with each bar tuned to a specific frequency. By striking the first bar, the signal would travel down the series of bars, with the final bar receiving the signal almost instantly. Exploring the feasibility of FTL communication with metal bars. While the concept of FTL communication using metal bars is intriguing, it is important to note that this is still a theoretical concept. Researchers are exploring various possibilities and models for achieving FTL communication, but there are still many questions and challenges to overcome before this becomes a reality. Potential real-world applications and limitations of metal bar communication. Possible applications of metal bar communication. While metal bar communication may not be useful for faster-than-light (FTL) communication, there are still real-world applications where this technique could be used. One potential application could be for seismic sensing. By measuring the time it takes for vibrations to travel along a metal bar, scientists could gather information about the composition and structure of the ground. Another application could be in the field of acoustics, where this technique could be used to detect and measure sound waves. The limitations of metal bar communication as FTL communication. Although it might seem like metal bar communication could be used for faster-than-light communication, there are some limitations to this method. First of all, the speed at which vibrations travel through the metal bar is limited by the speed of sound in the material. This speed is much slower than the speed of light, which means that metal bar communication cannot be used for FTL communication. Additionally, any noise or interference along the length of the bar could disrupt the transmission of the message. Ethical and societal implications of faster-than-light communication. The ethical debate surrounding FTL communication. FTL communication raises some ethical questions around the potential implications of faster information exchange between different parts of the world. One major concern is the threat to national security. If FTL communication became a reality, it could be used to transmit sensitive information or even weapons across the world in an instant. This could lead to increased militarization and an arms race between nations. Additionally, FTL communication could create new opportunities for cyber attacks and other forms of information warfare. The societal implications of FTL communication. From a societal perspective, FTL communication could have a significant impact on the way we live and work. It could revolutionize the way we communicate and interact with each other, enabling people to collaborate on projects or solve problems without the limitations of distance. However, it could also lead to further isolation and division between different communities, as people no longer need to physically travel or interact with others in order to achieve their goals. Current research and future directions in the field of FTL communication. The latest research on FTL communication. There is currently no evidence to suggest that FTL communication is possible, but that hasn't stopped scientists from continuing to explore the possibilities. One area of research is exploring the theoretical framework for FTL communication, which involves studying the properties of particles such as entangled photons. Another area of research is focused on developing new technologies and techniques that could potentially allow for FTL communication. Potential advancements and future directions in FTL communication. In the future, advancements in our understanding of quantum mechanics and fundamental particles could pave the way for the development of FTL communication technologies. Additionally, advances in materials science and engineering could lead to the creation of new materials that can transmit information at faster speeds than ever before. However, given the many limitations and challenges associated with FTL communication, it is likely to be many decades, if not centuries, before we see this technology become a reality. In conclusion, while the phenomenon of instantaneous movement in long metal bars holds significant potential for FTL communication, there are still many challenges and limitations that need to be addressed. Theoretical frameworks and models need to be developed, and significant advancements in technology will be required to make this a reality. However, the possibility of faster-than-light communication with metal bars is an exciting area of research that could have profound implications for the future of communication technology. Thanks for tuning in with us. Thanks for watching.